Decoupling single-tier web application. In this video, we will learn the advantage and the process of splitting our single-tier web application into a multi-tier architecture. And single-tier applications are good for starting application, but as you get more load and more visitor into your site, you want to optimize your application by splitting the workload of the database operation and the web server operation by putting them on separate server. Also, splitting the database will allow us to create replicas of our database or create a highly available database setup. And also for our web server front end, once we split our database out of it, we can start deploying a load balancer and load balance our web traffic into multiple front end web server, connecting all together to a common database in the back end. Now let's take a quick comparison between single tier and multi-tier application. Starting from single tier, where you have your web server, your database, and your application language compiler like PHP are all set up on the same server. The advantage that are associated with using single tier servers is it's easy for beginners. You don't have to do much with connecting your database outside or optimizing your database server. So single tier architecture is great for small application because it makes it easy to manage and also easy to containerize and migrate. As we done in EC2 and Lightsail, we have been using single tier architecture for this course, and we were able to use this single tier images to deploy quick snapshots of our image and replicate it into additional images or scale it up and down with only one server to worry about. Now, the downside for single tier, it's not possible to load balance web traffic because every instance contains a replica of the database inside. If you were to point at one of the server using a load balancer and this database get updated, and then the user relogin again and gets load balanced to another server, the data is not there. So the database is not common in all these instances, and therefore they do not share the same set of data. Also, the database itself is not highly available. So if you're running a critical application and you have a database installed as well, and this database happened to fail, or the service is being updated, or the server itself is being updated, you no longer have access to your database and it's not highly available. On the other hand, we have multi-tier application architecture, where we can deploy our web server alone on one instance and create a different instance for our database. And this application architecture is perfect for complex application that has a lot of load and a lot of visitors, and it puts less overhead on the server resources, because instead of your one server handling all the web requests and doing the database queries and write operations in the back end, and also compiling PHP or JavaScript files or any other language, this all puts extra overhead on the server. So the less resources you are running, the more stable, more smooth, and more support it can get. And with multi-tier architecture, we can also load balance our front end web servers, which will handle more user base, and we can use a back end database that can be commonly used by all these instances and can also support failover and automatic backups and a lot of other features. And the downside for using multi-tier architecture is the extra cost, because instead of paying for one virtual machine, now you're paying for two or more. And also there is more management overhead because you have to manage two virtual machines, and also to containerize or migrate your application to a different service or a different virtual machine, you have to do the same work twice or more. So this is all points to keep in mind when it comes to comparing single tier to multi-tier. And now we can see example of how we can decouple our application and split our single tier server into multi-tier server. And we will also do a comparison or benchmark the database on different services to see which one works best for our case. let's see how we can split our single tier server using AWS EC2. And now we will target our WordPress production site. For our decoupling project, we will try to install our database from this server into a separate EC2 instance running only MySQL. So from our server shell, we can run this Bitnami helper tool. This will allow us to see which services we run on our server. And if we check under Managed Services, Services Status, we can see that PHP, Apache, and MySQL are all installed and running on this individual single tier server. Our goal is to take a backup of our MySQL database and then use this database dump to migrate our database into a separate server. So first we need to grab our MySQL password, and this is usually located in the home folder under Bitnami credential files. So this would show us our password that we can log into the MySQL. We can verify this by going into sudo mysql-u, log in with the user root, and enter our password we just got from the file. And now we have access to our server. So we can start by showing our databases, and this would show us our database bitnami_WordPress. And this is the database where we are planning to migrate. So we can go ahead and exit out of our console. And now to take a dump of the MySQL database, we can simply do the command sudo mysql dump, and we will use the root username and password, and we will export our Bitnami WordPress into a file with the name wp.sql. And once we put our MySQL password, now our MySQL database has been backed up to this file. We do a list. We now have our wp.sql file. And now our database is ready for migration by deploying a separate MySQL server on our EC2 account. Now we can choose any Linux machine to launch our MySQL server to be able to migrate our database. So in this case, we can choose Ubuntu server as well. And we will launch it on the free tier also. And we're going to launch our application using a new key pair. This will be our database key pair, so we need to make sure that we are using separate key pair for every instance. And now our database server has fully launched. We can just give it a name to be able to tell which instance that is. And now we can go ahead and install MySQL server by doing the command sudo apt install MySQL server. This will install all the dependency. And once the MySQL installation is ready and we are ready to start our first time MySQL installation, we can set up a new root password for our server and remove all the unnecessary databases and access. Now our MySQL service is ready. Now if we check the status on our MySQL service, this is running on the server, and this server does not run any Apache or any web server. So this server is solely running the MySQL server for now. And we also need to move our wp.sql database dump into our new database server so we can import it into a new database. We can check our files, and under the home folder, I also have my wp.sql file. So now we can go ahead and log into our new MySQL server and create a new database. We're going to call it wp_dp. And then we will create our new user. We'll just call it dbuser and dbpassword for simplicity. But the difference this time is we are not accessing the web server from the same system. So our source will not be localhost in this time. We're actually going to be talking privately between our web server and our database. So for this, we need to go back to all our instance, and our WordPress server that is currently single tier is using this public IP address, but it also has this private IP address. So in order for us to allow the communication between our instance and the web server privately without having to traverse the internet, so this will be the IP address that we need to whitelist or allow inside our user permission. And the other way around, inside our WordPress web server, we will point to our database not using the public IP, but using its private IP. So all the communication will happen privately. We just need to allow this IP address in our user permission. by going into our user, and we're just gonna open our filter and paste our private IP address of our web server. So only the web server private IP would be allowed to use this username and password for authentication. And now we can save our user. And finally, we will grant access for our new database to our new username coming from the WordPress private IP address, and flush our privileges. And now we are ready to import our WordPress database into our new server. For this, we will need to use the MySQL command again, and we will just define our database to be wp_dp. This is the database where we want to import our SQL dump into. So we will put our reverse arrow and just choose wp.sql. And now we can put our MySQL password, and the migration will take place very quickly. And now we have a replica of our database inside our new server. And to do the cutover on the WordPress side, we need to modify our wp-config file. This file will be located in the main directory of WordPress, and it contains all the connectors for our database. So we would need to change our database to use the new database we created on the new Ubuntu server, and also our new username and password. And finally, for the MySQL host, it will no longer be localhost. We actually have to go back to our EC2, and in our database server, we can point out to our private IP address for the database. So we can update this localhost to our database server IP. And now our wp-config file is ready. We also want to make sure we come to our database server and check our inbound rules. We have to make sure that the MySQL port is open. We can go under the security group and we can edit our inbound rules. And we just need to add a new rule to allow our MySQL server access by choosing the MySQL from the list. And ideally, we want to restrict this only to the web server IP address or subnet, or we can also restrict by security group. We can go ahead and choose our launch wizard one. This is the security group assigned to our web server. And now our security group would allow us to access the MySQL server on the MySQL port. So now we need to go under etc/mysql/mysql.conf.d. This way we can find our MySQL configuration file, and we want to check our file to make sure we are allowing remote connection to our database. And by remote connection, we mean the connection that initiates outside of our database server, which is going to be our case because we are communicating privately between our web server and our new database to be. So we can modify our MySQL d.conf, and inside our MySQL configuration file, we will see basic settings like our listening port and different settings. We can change the bind address to 0.0.0.0, and we will keep controlling our MySQL using the security groups. We are not sacrificing security by opening it to all IPs. Now we can save the file and finally restart our MySQL server. And now if we try to access our WordPress again, now we are accessing our blog using the separated database running on a separate machine. Now if we compare the benchmark from our database access between our SingleTier server and our separated MySQL server, those are the benchmark coming from our SingleTier server. We can see our benchmark for MySQL is totaled at 0.658 seconds. Running it multiple times in a row gave us this average result. And if we compare this to our separated database server, now we can see that the MySQL version is different from our SingleTier server, but we can verify that this is Ubuntu 18.04. And we will see the MySQL bench is totaled at 0.358 seconds. So this benchmark is showing us a massive improvement of the performance and speed of our MySQL server deployed separately from the web server. So our choice for deploying database for bigger application and for faster deployment is to deploy the database on a separate server away from the web server. And that's how you can decouple your web application from a single tier to multi-tier architecture. Thank you for watching.